keep doing this every time. The safety precautions and things to make sure things work out. C, cool it. This is very important before you centrifuge. So we keep our H2S fumes minimized in the lab. Procedure 6, I don't think there's any precautions there except make sure you label the test tube that you're saving for procedure 11. Procedure 7, as I say, the other possible reason for not finding mercury is if you don't keep replenishing the dilute HNO3, it eventually gets fairly concentrated and may be concentrated enough with a little bit of residual chloride to dissolve the mercury to sulfide. Okay, so that's one of the reasons. So procedure 7. I didn't say anything except what? Label. And I think people sometimes get confused with all the steps in here. You just have to be organized. You don't say things that you don't need. For instance, in procedure 5C, after you've completed the precipitation, and there are multiple trials to make sure you've got complete precipitation, at the very end, you may continuously get a faint white precipitate. What is a faint white precipitate? Sulfur. In other words, thiosediment breaks down to give you sulfur. So if you work with it long enough, it's going to make sulfur. So at that point, you can sort of stop doing it. But you're going to combine all the precipitates into a single test tube. That's the precipitate you use for procedure 6. Not any part of the precipitate, but all of the precipitate from 5C. A couple of people have shown me precipitate, and they said, well, they're on procedure 7. How can you have precipitate to show me unless it's one of your confirmatory tests and you're at procedure 7? Because you used up all your precipitate in 6. And when you got the precipitation in 6, used everything in 7 and saved the decantate from 6 for what I'm going to talk about today. This is the mixture of complex ions. Okay? So you go 7, 8, 9. And I said, you want to add a lot of 15 molar NH3 so that you have the deep blue color from the copper. If you don't get a deep blue color at that point, you want to examine what you've done because somewhere you picked up the wrong test tube. The most confusing place for this to happen is the very first part of procedure 7 where you're adding the 3 molar nitric acid and 3 molar nitric acid, replenishing it. When you transfer to the test tube, you should have about 15 drops in your test tube when you transfer from the casserole. And there should be some black precipitate. When I did the mercury test, I pointed out you only want to add 1 drop of tin 2 chloride, but before that, where it says use the aqua regia mixture, you want to boil, the book says 1 minute, I said 3 to 5 minutes, but again, you keep replenishing your HCl, HNO3. These are now the concentrated reagents, so you're sure to dissolve the mercury 2 sulfide. And the mercury 2 sulfide is black. If you keep having a black precipitate, it means you boil longer with the aqua regia. Okay? Eventually it should all dissolve and finish out that test and save the precipitate. A lot of people told me they weren't getting. And then the decantate goes to procedure 8. That's where you're doing your lead test. And you go with the decantate from procedure 8 before you complete the lead test. In other words, the thing you're saving always is discussed in the first couple of sentences of each procedure. Then the rest of the procedure goes through the confirmation part of the test. Okay. So finally you got the procedure 9. I said make sure you add enough 15 molar ammonia. Here's your bismuth test. I'm not going to go through all of that. I did that already. But what I wanted to get to was 10, because there's an A part and a B part. Okay? And you're dividing your solution in half. Now this solution, both of these solutions are going to be very basic. To the 1/2, you're adding acetic acid till you have it slightly acidic, and you'll see the deep blue color of copper disappear, because you should have it at this step unless you forgot to put copper in. But it's pretty hard to miss copper because it's a nice bubble of blue solution. You calculated the drops, you put it in. You've been following it all through here. It says what happens to copper each time because it's pretty visible. Right in here, at about procedure 7 and 8, it might be a very pale blue color because you're diluting it out. But right here it comes back a deep blue color. Here this will have a bluish color. You make it acidic, the color will diminish. It won't go away completely. And when it says decolorized, it doesn't mean colorless. You're adding the potassium hexacyanoferrate. Okay? That part's out in the laboratory. So that's what we call 10A. Now 10B has 2 parts. The first part of 10B is if you didn't get a positive copper test here. Copper test means you got a reddish-brown precipitate. The 10A says if you didn't, then you just add ammonium sulfide. Since you're doing your known right now, you should get a copper test because you put copper in there. So here's the part I wanted to get to remind you. KCN procedure. And I pointed out you need 2 test tubes, one's your sample, half of your sample, whatever it is. So one of the test tubes. The other is your waste tube with 15 molar ammonia. I went through this the last time, I'm just reminding you. And you come up to the stock room. I'm not going to give the KCN out too late in the day because I have to collect your waste tube before you leave. So I add the KCN. I actually test first. What I'm checking for is to make sure this is basic, because lots of times people acidify the whole thing and then they bring me an acid solution and they don't even know what they're doing. When I fall, and I haven't fallen over because I check it first. But the idea is, after a quiz like today, I double check it. Coming back to this thing, so I check it, add KCN. You add ammonium sulfide. Centrifuge if you can't, wash the precipitate, everything goes into the waste tube here, return waste. And what I do, by the way, is I just flush it into a container back there. I have a lot of base in there. I eventually add bleach to it, and it converts the cyanide to cyanate, which is harmless. Okay? But I rinse the test tube out with 1 or 2 with a drop of ammonia, water and ammonia, and then I give it back to you, and you can clean it at that point and continue on. Okay? Up here. Procedure 11. And the first thing is, you want to look at your test tube, because there should be no black precipitate in there. If there is black precipitate, it's something from this group that might have been in colloidal suspension and settled out. So you want to get rid of any black precipitate, either by decanting, or probably the best bet, since it was originally colloidal, is using your pipette to suck out most of the liquid, leaving behind the black precipitate. Now, one of the things people always complain at that point they say my solution turned solid. That's because, as it stands, the sulfur crystallizes and actually forms a layer of sulfur on here. So when you turn your test tube over and decant, nothing happens. Everybody runs up and says it got solid. That's because of the solidification of some of the sulfur there. That's nothing to worry about. The thing I'm worried about, if you see black precipitate here, you want to poke your pipette through there and suck out the liquid. The sulfur we don't worry about because it came from the decomposition of the ammonium sulfide in this particular case. Okay. Then, after you've gotten rid of the black precipitate, if anything, it says add 6 molar HCl. You want to do this in the hood, not back at my sink, because here's the sort of thing you have. There's one of the complex ions in there. You add HCl. It's going to produce H2S as it dissolves your complex, as it reprecipitates your complex ion. And then you make this precipitate again. So you're going to make H2S in this procedure 11. So you want to add the HCl in your hood. This is one of the times you can take the HCl to your hood. And it says here, add 6 molar HCl with constant stirring until the solution shows an acidic reaction tested with litmus. The problem is, students tend to get, and he says, see note 2 gave you a molecular equation, I wrote a net ionic equation. The problem is, if you get it too acidic, you will start losing your antimony and tin. So you want to add about 2 drops maximum, 6 molar HCl. The way you want to do it, add 1 drop, mix, centrifuge. Add 1 drop. You get the idea. Mix, centrifuge. If each time you add a drop of HCl, you get precipitate, you centrifuge it, you get precipitate, centrifuge it, you don't get precipitate. Don't add any more HCl. In fact, what I always suggest is add a maximum of 2 drops of 6 molar HCl, then you switch to the 2 molar HCl. Still dropwise. No more precipitate. Here's another one of these things. The precipitate. Whoops, I'm sorry, I got it backwards here. Precipitate are the sulfides you want to collect. What you don't want is the decantate. Okay? So in here you're going to have sulfur. And you also have the other arsenic precipitate. In other words, you have both oxidation states for arsenic. So these are all your yellow precipitates in there.